Hi, this is Kevin Trainer, and welcome to my lecture on Chapter 12 of the Murach's third edition MySQL book. Chapter 12 is about how to create views. And I'm going to leave the objectives for you to read on your own, as usual. So here's the create view statement. We start with create view. We give it a name. In this case, it's vendors underscore min as, and then there's a select. So we're selecting vendor name, vendor state, vendor phone from vendors. Okay. So what we get is what Joel Murach describes as a virtual table that's represented by the view. So views are virtual tables. They're virtual in the sense that they're not physical, okay? And they don't persist in between uses. Uh, when we refer to a view, the select that created them is run, okay? And then the select that contains the view uh, that refers to the view, it runs and gets its result set. And then everything goes away. Okay? Now, I want to point out that we've seen this before in two situations. Okay? We had, first of all, we learned how to do an inline view. Okay? And in fact, let me find the slide where we were doing that. I'll be right back. Okay, I found the slide. It's in chapter 7, and we create an inline view by placing a subquery um, in the from clause. Okay, so instead of naming a table, we provide a select, and the result set becomes the table. Okay, and we give it an alias. We give it a table alias because it doesn't have another name to refer to it by. So if we want to make some kind of prefixed reference to the columns in that table, quote unquote, table or inline view, we can use that whatever the letter is that we use for the table alias, in this case a T, so we could refer to as, let's see, we've got the vendor state, vendor name, and sum of invoice total as sum of invoices. And if we wanted to refer to them in the outer query in a very explicit way, we could say T dot vendor state, T dot vendor name, T dot sum of invoices. All right. So that was an inline view, and we learned how to do that. Okay. We learned how, towards the end of chapter 7, one of the new features in MySQL 8 is this thing called a common table expression, CTE. And here are CTEs right here. And the interesting thing about a CTE is it pretty much looks like the subquery that we were using earlier in chapter 7, except that it gets a name. Okay. And because it has a name, we don't need a table alias. So for instance, if we want to refer to this CTE within a query with a prefix, well, we just use the name that we have here. We would say summary.vendor state, summary.vendor name. Okay. So these are an improvement over inline views. in a couple of ways. One is that they have a name. The other is they don't clutter up the enclosing select. Okay, so the enclosing select uses the CTE with a name, okay, and it just gets referred to like any table, and so the query that encloses this logically is a lot cleaner using CTEs than inline views. Well, how about proper views? That's where we are now. Okay, so in the proper view, what we have is we do the same thing. We can name a view. We create a view and we give it this name vendors min. The name and the definition of the view persist indefinitely in the system. So that's an advantage that they have over, for instance, CTEs. They do have the same benefits that in the select that uses the proper view, we're using the name of the view instead of having to enclose the text of the select that's used to create the view. Okay. Now, in all three of the situations, these are views of some sort or other, and the predominant property of a view is it appears to be a table without actually being a physical table. So this phrase that Joel Murach is using here, virtual table, that's a really nice way to think of it, okay? It gets built on the fly every time we refer to it, okay? And then the select that is using that view, it gets to use it, and then the result set, the virtual table that we use, it goes away when that query is over. Okay? So what they're showing us here down at the bottom is a virtual table that's represented by the view. Okay, and this really doesn't. How can I say this? To look at this, you would have to do a select. Okay, because every time we refer to the view, it gets built. Okay, but in between references to the view name, it disappears. Okay, it's rebuilt every time we go through. Okay, and what's the use case for this? Well, in this case, I think min means minimal version of the vendor's table, so it's just got 3 columns. That's why that's what we mean by min. Okay. So here's a select that uses the view, kind of the same way we did with the CTEs that we learned about in the end of chapter 7. We just use the name. Okay, the difference between a proper view and a CTE is that the name persists over time. The only way to get rid of the name is to drop the view. Okay, whereas the names that we use in a CTE are only available for the life of the query that we're inside. Okay, so here we are selecting all columns from vendors min as though it were a table name, where vendor state is equal to CA for California, order by vendor name, and this is what we get. 75 rows. Okay, if we had asked for all of the rows, it looks like we would have gotten 122. Okay. Now, for certain views, if the view is appropriately uncomplicated. Okay, we'll get into the rules in a couple of minutes. If it's appropriately uncomplicated, it can qualify as an updatable view. Excuse me, updatable view. So, as we're going to learn in a bit, if we have a properly updatable view, uh, and we write the appropriate update, we can actually use a view to do the update instead of a table. Okay, and that turns out to have some benefits that we'll talk about in a couple minutes. And of course, the view, once we create the view, it's going to persist under that name until we drop it. So to drop it, we say drop view, and then we use the name, and in this case, vendors min. Okay. So what are some of the benefits provided by views? Okay. I think I would go. I'm not sure these are all benefits. I think they're use cases, right? Why would somebody use a view? Okay, and the first one we talk about is design independence. Okay, um, there are some times when you're doing a design that you may decide because of performance reasons or something like that, you want to take what would have been a single table and break it up into two. Okay. Um, and yet, maybe you don't want to make that obvious to the users. Okay. So you can create a view that combines the two. Okay. And then give the view to people to use. And they'll be able to use that as though it were a single table. And if in fact we change the design, uh, we can simply change the definition of the view, and all the queries that we wrote against the original view are going to work because the changes in, say, let's say we went back to one table, or we split it again, we went to three. Well, as long as the result set from the view did not change, well, then the query that builds the view could change. It could take the data from a single table or from two or from three. Um, and the fact is, you would insulate your code from the impact of design changes in the table. So the next one is data security. Okay. And here's the use case. Maybe you don't want some of your users seeing some of the columns, or more importantly, some of the rows in a table. Well, here's what you can do. You can, instead of giving them access to the table, you give them access to a query. And that query would return a result set that just wouldn't include any columns you didn't want them to have access to. Or the where clause in that query would eliminate rows that you didn't want them to have access to either. Okay, so that is the data security use case for views. Simplified queries. This is especially good for people who have some data that they have a large population of users that they want to be able to query, and yet the queries would include multiple joins, maybe 4, 5, or 6, or 7, or 8 joins. Well, do you really want to train all your users to be able to write queries that are that complex? Well, there's a certain argument that would say yes, you do. But the people who would provide a view for that would say, no, you don't want to do that. You want to create a view that does all the joins and give that view to your lighter users such that they're doing simplified queries against the view. So the last um, item that we have here, updatability. It's not really a use case. It's not really a benefit either. Okay. It's an option. Okay. One of the nice things about proper views is that they may be, if the, if you follow certain constraints, they may be updatable. So the people who you gave views to, because of either design independence or data security or simplified queries, uh, if they also need to do updates, provided that this view qualifies, and provided that the way that they do the update qualifies, they might be able to update the view instead of the underlying table, which they often refer to as the base table. Okay? So that's how and why people do it. Okay, so here on slide 7, what we realize is just like when we were creating a database, um, when we or creating a table, okay, uh, we sometimes have this situation that we're not sure if we already have one by that name, okay? So the safe thing to do is to use this optional syntax or replace, okay? Because if you already had one, okay, uh, you can replace it and you can keep the server from coming back and saying, oh, I'm sorry, you can't do that. I already have one with that name. Okay, what you're saying is, if we already have one with that name, well, we're redefining it. Okay? So you can say or replace. That's the option I just talked about. Or there's with a check option, and I'll get to that in a minute or two. Okay, so this is a view of the vendors that have invoices. So we say create vendor's phone list, which is a horrible name. Okay, I guess the idea here is we want to phone the vendors with whom we have invoices. If we want to make a list that's really tailored to that job. So, uh, so this is a phone list for vendors that have invoices. Perhaps that was just a little too long of a name. Okay, so we are selecting vendor name, vendor contact last name, vendor contact first name, vendor phone from vendors, where vendor ID is in the list. Select a distinct vendor ID from invoices. So if this isn't a vendor that has invoices, it won't be on the list. So it's not going to be in the result set that creates that runs the view. Okay, pretty cool. All right. Here's a view that uses a join. Okay. Um, so they use create or replace view vendor invoices as select vendor name, invoice number, invoice date, invoice total from vendors join invoices on vendor ID. Okay, so this is only going to include the vendors who have invoices. All right, and it's going to include their invoice total. I'm sorry, I take that back. It's going to include all of the invoices and their vendors joined together, but because it's an inner join, a regular old mom and pop join, it's not going to include information about vendors who don't have invoices. That's what I meant to say. Here's a view that uses the limit clause. Now, just want to back up. You don't see that the joins that the views that we've seen so far have an order by. Okay, largely that's probably because Joel Murach is not as worried about using order by as Kevin Trainer. Okay, but it turns out that for these views that we've seen so far, we don't need an order by for the following reason. Okay, uh, our view defines a virtual table. Okay, and according to the SQL standard, the order of rows in a table is undefined. Okay, it can be different implementation by implementation. So in MySQL, if you don't specify an order, they tend to come out in a primary key order. Okay, in a very popular relational database, Postgres, they don't come out in any reliable order. And that's the reason why I have you do order by on your typical selects. But it really doesn't make sense in almost every case when the select is forming a view, because how are you going to get order in the result set? Well, you're going to use this view in a select, and that select is going to have the order by. Okay, so you don't have to order the view. That's kind of ordering the data twice. It doesn't make sense. Okay, so plain old views, we typically don't have an order by on them. The next example is the exception to that. Okay, because we want to get the top 5 based on a particular order. Okay, so we can we got this thing, top 5 invoice totals is the name of the view. We're getting the vendor ID and invoice total from invoices, order by invoice total descending. That's going to put the highest at the top of the list, and we're going to say limit 5. You can only do this effectively with an order by. So what I want you to do when you're coding the selects in a view is to leave off the order by unless you're doing this kind of trick that we see here, where we're using the limit in order to create a top 5, a bottom 5, that kind of thing. Okay? Other than that, you can leave the order by off. Okay. Here's an example of a view that names all of the columns in the create view clause. Okay. So normally we just whatever names columns have in the select, we just get those names in the view. Okay, that's usually okay. Okay, 8 times out of 10, 9 times out of 10, that will work fine. There are times where, on the basis of the where clause, for instance, the context of these things is changing, and we want to provide other names. We want to provide a different set of names that reflect the context we've created with our view. Okay, so you can provide new names for all of the columns. This is especially helpful if you have a calculated column. Okay, in this case, we had invoice number, invoice date, invoice total. Those are all just plain columns. But then we have the formula for balance due. So what Joel Murach did up here is he reused the names invoice number, invoice date, invoice total, and he put the balance due here as a way to give the formula column, the calculated column, name. Okay. Now, you can do it in a simpler way if all you need to do is to give a name to a calculated column. And we're going to show you that next. Okay. If all you need to do is to give a name to a calculated column, you just use a column alias. So in that case, all of the columns in the result set, which of course that's what's creating this virtual table, all the columns in the virtual table take on the names of the columns from the tables that they came from. Okay, and that usually works okay. And if you have a calculated column, well, you just use a column alias to give it a name. Okay, so in terms of how often you would use one approach over the other, well, the approach we see here, I think you would use very often, and the previous one less often. Okay, that's typically where you need to change names the original columns to either avoid duplicates or um, uh, create further context. Okay, but the far and away the more popular use case is the second alternative that we've seen here, and that's how we're used to doing this in selects that have a calculated column. Okay, here's a view that summarizes invoices by vendor. Okay, so so we're saying create a replace view, invoice summary as, and then we're saying select the vendor name, the count of the rows as invoice count, the sum of the invoice totals as invoice total sum. And then we're using vendors join invoices on vendor ID. Group by vendor name. Okay, now here's something I want to point out. One use case for views that we didn't really talk about explicitly. I guess it would come into the use case that we talk about of simplifying the query. But there are times when you want to have on a line in your result set, you want to, let's say that you wanted to know for each invoice, right? You wanted to know the amount of that invoice, okay, and you'd want to show the percentage of what did that represent as a percentage of the total invoices in that group. So let's say we group by vendor name, okay. We'd want to say, well, we have all these invoices, and one is 50% of what we owe that vendor, and the next is 10 and 8 and 10 and 5 and 5 and 5 and 5, or something like that. I probably added up to more than 100%. Okay, now to be able to calculate that, you would have to know both the sum amount and the detail amount. Okay, so the trick is you build a view that summarizes it based upon something like a vendor that gets to the vendor total. And then you join that back to the detail, the table itself, and you can create a report which shows the amount of the invoice and the percentage it represents of the total invoices from that vendor. And you can do something very similar to this in uh, the uh, capabilities that we saw at the end of chapter 7 and a little bit in chapter 11. Okay? But this is a way that you can do it without the new features. Okay? So these summarized views are popular for one of two reasons. Uh, uh, One, that as soon as I say it's a number, I think of one more. So I should never do that, but I do. So the first one, you just want to show a summary. Okay. Um, the second one is that you need to create some kind of analysis that includes the detail lines, like the invoices, and then some kind of a summary value for the group that it's in, like the vendor group, to be able to do, say, percentages. Okay, that we talked about. The third one is there are times when you want to have kind of levels of summary. Okay, so you can have a summary by vendor. You can have a summary by sales region. You can have a summary by this, and then you can come back and either create reports that show the totals, or again, you could go all the way back to the detail line, and you could take that and join it to the summary view or views, and you could show, for instance, a particular invoice is uh, 40% of the amount owed to that vendor. You could maybe show that it's only 18% of the amount owed to all vendors. You could do some pretty interesting analysis by creating these summary of views and joining one or more of them back uh, to a detailed query of the original table. Okay. All right. Where do we go from here? Okay. Now, remember, I said a little while ago that we have some views are updatable. Okay. And so then the question comes up, well, what are the requirements for having a view be updatable? So I have a couple of ways that I describe the rules for this, but here's my shortest version. Um, you can't update a view that's too fancy. Okay. The more simple the select that created the view, the higher the possibility is that it's going to be updatable. Okay. So the fancy features of the select are the things that get in the way of a view that's built on that select being updatable. Okay, so let's look at the fancy features we can't use. Okay, it can include a distinct clause. Okay, it can include aggregate functions. It can't include a group by or a having clause. It can include the union operator. Now, I don't know about the union operator. I'll have to think about that a bit. But these first three distinct aggregate functions, group by or having, these things all uh, get rid of data from the original rows. Okay, as soon as you use aggregate functions, you don't have regular rows. You have summary uh, rows. Okay, and group by and having are based on summary rows. Distinct causes duplicate rows to be it dropped out. And the fact is, it's too hard for the server to map back to the underlying table. We've done too much manipulation between the underlying table and the results of the query to be able to do an update against that the query that created the view and have the server be able to find its way back. Okay, that's what I mean by too fancy. All right, so let's see some examples of this. Okay, so here's a create view that creates an updatable view. We're going to create a replace view balance due view. Okay, as select vendor name, invoice number, invoice total, payment total, credit total, and then we have the calculation for balance due as balance due from vendors join invoices on vendor ID, where the balance due is greater than 0. Okay, is that updatable? Yes, it is. Okay, it does have a calculated column, and we're going to see that we can update that calculated column, but it's a simple enough query that's used to create the view that we can update the other columns. Okay, so here's what a successful update would look like against the balance due view. Update balance due view, set credit total equal 300, where the invoice number is equal to the number that we see. And it works. We say one row affected. Okay, so that worked. Let's see some other possibilities. Okay, we'll get this. There it is. Here's an example of an update against that same view. So that's a proper updatable view. That doesn't mean you can update every column. In fact, you can update a calculated column. So let's just see. We say update balance due view, set balance due equal to 0, where invoice equals this. Well, it says error code 1348, column balance due is not updatable. So the view is updatable, but that column is not. Why? Well, because when you really think about it, there's a lot of different ways that you could set the balance due equal to 0. Let's just go back and look at it. It involves invoice total minus payment total minus credit total, okay? And based upon whether it's too high or too low compared to 0, then which of these three are you going to adjust? You could, in theory, adjust any of the three. It's too fancy. It's not going to be able to do it, okay? So this one individual column is not updatable, although the view as a whole is, because it's not using anything like distinct or fancy grouping and aggregating features. Okay. the check option, I think, is a lot of fun because of the way that I like to describe it. And hang on one second, and I'll do that. Uh, Being the whimsical guy that I am, I'd like to describe the check option in terms of uh, time travel. Now, most of us have seen science fiction movies or science fiction TV shows or read novels or short stories where there's time travel. And generally, they have the rule that you can go back in time, but you can't change anything that would affect you, right? Like you can't keep your parents from being introduced to each other. Uh, some of them go so far as you can't change anything that would change history. Okay, there's they'll say, well, you change these things at your peril. You could come back and be dead, right? So it gets you thinking about what would happen if you went back and you changed the underlying rules. Now you come back to the present, it's going to create a mess. Well, likewise with views, okay? If you create a view that has a where clause, okay, that where clause is going to control which rows are um, wind up in the result set. And as a result, they wind up in the virtual table that is the result of the view. Okay. Now, if you don't use the check option, uh, this is like the time travel plot where they say you can change whatever you want, okay, but do it at your peril. You could come back and you could live in Nazi world. You could come back and you could never have been born, right? You could have all those kinds of problems. That's without the check option. Okay. So, for instance, you could update you could update a row in the view by changing the balance due as a result of changing these underlying columns that are used in the calculation for balance due. And it could no longer satisfy that where, well, it's going to blink right on out of the view. You're going to lose a row. You could theoretically you could lose a number of rows. Okay, that's like coming back from your time travel and finding out that your cousins don't exist. They're just gone. That whole line of the family never was born. Okay. Uh, okay. Now, how do you prevent that from happening? You turn the check option on with check option. So that says, okay, we'll do the update, but as soon as we find a change that would uh, remove a row from the view, we're going to blow it up. We're going to throw a check option uh, uh, error. So this, what's the time travel equivalent of that? Well, you go back and you try to keep your parents from meeting, and a buzzer goes off and it says something gives you a shock. You can't do it. Okay, it keeps you from changing the history that you're based on. Okay, so if you think of the metaphor of time travel and the general rules that we've come to understand for it, you'll understand the check option. Okay? having a hard time getting on the next slide. There we are. Okay, so here's an example of this. So we select from the view, we select all the columns from the view, vendor payment, where the invoice number is equal to PO 608. And so you get it. That's Molloy lithographing ink. Okay. And then you go on, I'm sorry, you go to the next one and you set the payment total to 400. Okay. And that works fine because how much did we owe to Molloy? Well, I think we owed, uh, invoice total was 20,551. So we owed quite a lot. Okay. So if we pay off 400 of it, well, uh, it still occurs in the view, and that's fine. Remember, this view has the check option. It's this one uh, here with check option. Okay. So we can do that, and then we can see the row after the update. Uh, we still owe quite a bit. Let's say we had a credit total too. So we paid 400. We've got a credit at 1,200, but still that's only 1,600 against 20,000. We're fine. Okay, so we haven't broken the time travel rule. So now we go and we try to set the payment total to 30,000. That is going to remove it. Okay, and because the check option, because that's going to create a surplus of something around $10,000. Okay, an overpayment of something around $10,000, and as a result, we get error code 1369, check option failed, AP vendor payment. Okay. You tried to keep your parents from meeting. Okay. And whatever. You write, the script. You can't, something is preventing you from doing it in this plot. You get a shock. You can't find your parents. It's whatever it is. It keeps you from changing history. All right. Okay, now here's a statement that creates an updatable view. Create or replace view IBM invoices as, and we get these things. We assume that vendor ID 34 is IBM. So the contents of the view look like this. Okay, looks like there are two rows that are going to qualify to be in the view. Okay, so now we try to do an insert. Okay, it generally, okay, when we say that views are updatable, that also means that we can do an insert and a delete. Okay, so now as we're going to find out now, with limitations. Okay. So we're going to try and insert. We're going to try to insert into IBM invoices. That's the view, invoice number, invoice date, invoice total, values, blinko, blinko, blinko. The response, error code 1423, field of view, AP IBM invoices, underlying table doesn't have a default value. So this is another case where you can try to use a fancy feature all you want, but if the rules of data integrity say, for instance, that when you insert into the underlying table, which I assume is invoices, you have to provide values for every column that is not allowed to be null and or doesn't have a default. Okay, so there was a required value that we didn't provide, and there was it didn't have a default and it wasn't allowed to be null. Okay, so just because we're using a view, we can't break the rules of database integrity. All right, so the view that we're trying to use to do an insert needs to be sufficient to do a proper insert on the underlying table where we're trying to do it. Here's a delete that fails due to a foreign key constraint. We've seen in the past that we can try to drop a table. We can try to delete a row with a normal delete. That's not going to work. Sometimes because of a foreign key constraint. We can try to drop a whole table, but if that's going to break relational integrity, that's not going to work either. Well, here it's the same thing. We don't suspend the rules just because you're using a view. So here we're trying to delete from IBM invoices where invoice number is, and there's the value. And it turns out it says cannot delete or update a parent row. A foreign key constraint fails. In invoice line items, we have line items for that invoice. We can't get rid of that invoice before we get rid of the line items. So just because we're using a view, that doesn't change the rules. Okay? Now, here are two deletes that succeed. Delete from invoice line items where invoice ID equals, and then we select the invoice IDs that are for that invoice. Then we say delete from IBM invoices where the invoice number equals that. Now, that's going to work. By the way, we only see the response from the second of these two deletes. Okay, so it would have probably said up here, it probably would have said 2 rows affected. And now when we get rid of the row in IBM invoices, it says 1 row affected. Okay. So those work because we did them in the right order. And we've got a bunch of questions. We have a bunch of exercises in our final project where you have to remember to go get rid of the rows in the dependent table, call it the child table if you want, before you delete the row in the independent or the parent table. So this is a good example for us because I think we've got 2 or 3 situations in the final project where we need to remember this. It doesn't have anything to do with views, but it has to do with not breaking the foreign key constraints. Okay, so I'm looking for one more thing. Okay, so I want to go back to insert, okay? Because when we were talking about insert, we didn't talk about one of the important rules, and that is when we're doing an insert, we can only insert to one table, okay? When we're doing an update, we can only update one table. So this is a part of when we're trying to use an updatable view. We might try to do something that breaks that rule, which is kind of qualifies as trying to do something too fancy. Okay, so when you're doing inserts or or updates or deletes, you can only do them on one table at a time, even if you're using a view. Now, when you think about it, we have a lot of views, potentially uh, summarizing views or summarizing views would be too fancy. But let's say we have a view that derives from a single table and it has quite a few of the columns in it, but not all of them because we didn't want to show you all the columns. Okay. Well, you can do an insert against that if you provide the minimum columns that we need for an insert with that view, and that would be fine. Okay, because you can only insert into a single table. You could do a delete against that because it would only be trying to delete from a single table. You could do an update against that because you would only be trying to fix something in a single table. Okay, so one of the fancy things we can't do is we can't do these update, insert, delete things um, in views that are going to try to change two tables at once. That's one thing that when I give you my general rule is you can't try to do anything too fancy. That falls into too fancy. You're trying to affect two tables at once. Okay. Um, okay, back here, a statement that creates a view. Vendors SW, that must mean Southwest. Okay. And it includes where the vendor state is in California, Arizona, Nevada, New Mexico. And then we say create or replace view vendors as, and now we've added some more states to our definition of what we mean by Southwest. Okay, and then we can drop a view. Okay, now the question comes up from time to time, can we alter a view? Yes, in the spec it says you can alter a view, but it doesn't make any sense to alter a view where you can easily recreate it. Okay, so this replacing the view here is typically the way that we adjust a view. We never fool with alter table. And again, I'm sorry, that would be alter view. Uh, these these alters are really things that make sense for conversions and not for changes when you're trying to get something right the first time. So this way to change a view is just the way to do it. Okay, that's it for views. Again, we do have some alternatives for these formal named views. We could be using an inline view. Inline views are temporary, but they're kind of sloppy because the select gets right in the middle of the outer select. We could be using the CTEs that we learned in Chapter 7, the Common Table Expressions. Those, I think, are a good alternative for these formal views, the name views. The decision between one and the other should probably be, do we need to hang on to this definition of the view? Do we want that to be sort of shared by multiple queries? If we have a bunch of selects that are going to use the same view, then we'd probably want to use a named view. Okay? If we have only one, well, they probably want to use the common table expression. Okay, that's all we have. I'm going to say bye until next time. Bye bye.